Certainly, the majestic aurora is one of the most remarkable and fascinating spectacles presented to us by the heavens at night. In Alaska, the aurora is not always in the northern sky, as it appears from lower latitudes. Here it often comes directly overhead and goes into the southern half of our sky. The great bands of glowing rays, 1,400 miles east to west, extend from horizon to horizon. Throughout the ages, man has viewed the aurora in awe and wonder. But it's more than an object of awe and wonder, it's a subject of scientific curiosity and study. And one center for this study is the Geophysical Institute of the University of Alaska. Here, Dr. Sidney Chapman, a leading authority on solar disturbances and their effects on magnetic fields, aids other scientists and graduate students like myself in our attempts to unravel the riddle of the aurora. I've been a part of this research for the past 2 years. But the story doesn't begin here. It was 7 years ago, in high school. Dr. Chapman came to talk to our science club. He told us about his life as a scientist and the tremendous range of opportunities open to young people today. He mentioned that since the University of Alaska was our northernmost academic community, it offered many unique chances to study polar phenomena at first hand. Well, he aroused my curiosity, and I wanted to see for myself. Going to the University of Alaska was like discovering another planet. The long shadows gave the campus a strange appearance. It was almost a perpetual twilight. I got used to these new surroundings much quicker than I got used to the rigorous study schedule. The long hours in the labs and classrooms gave me plenty to do. My books became regular midnight companions. But during my undergraduate years, I had a chance to see science as a way of life as well. Because of the government-sponsored projects, there were many research installations around Fairbanks. The wilderness fairly bristled with radio telescopes. Alaska had another gold rush, research. Some friends of mine worked at Belaine Lake Ionosphere Monitoring Station. The heavy snows gave them some problems too. They flipped a coin to see who would do this job. The largest of these installations was the Gilmore Satellite Tracking Station. Its 85-foot tracking dishes were nestled in a valley and surrounded by a ring of mountains which cut down electrical interference. One day we jumped in the snowmobile and went up to see one of the sighting towers. We wound our way up 7 miles of trail through snow about 5 feet deep. As I became better acquainted with these installations, I began to see how my studies related to the instruments out in the wild Alaskan ranges. I wanted to become part of a research team. In graduate school, I found that my 16 years of education had been years of preparation, years that provided me with the basic tools of knowledge. Now I had to dig in. Dr. Chapman's lectures gave us a background in the history of research on the aurora. This chart was first published in 1860. It was the result of years of work by Dr. Elias Loomis of Yale University. He spent years questioning people who had seen an aurora. Finally, he had recorded enough detailed information to show that the auroral activity centered around Greenland. This, and not the North Pole, was the true geomagnetic pole. As our studies became more complex, our questions became more frequent, but Dr. Chapman always had time to help us. Later in the school year, we began our studies on the modern tools of research. One of these tools in use at the university's observatory at Esterdome was the all-sky camera. After seeing the aurora at first hand, it was easy to understand that no camera can capture its true beauty and magnitude. The all-sky camera, by taking a picture of an area of 360 degrees and 1,400 miles of sky, is by far our best device. By taking time-lapse photography of this vast portion of the midnight sky, we learn something of the aurora's scale and pattern. And when these pictures are placed together, we are able to see its activity and change. These undulating rays of light, which have perplexed man for thousands of years, are believed to be caused by a flow of charged particles from the sun. These particles, imprisoned by the Earth's magnetic field, collide with our outer atmosphere and produce this glow. The fluctuation of these strange lights is relative to the intensity of the solar storms. The Geophysical Institute first began using the all-sky cameras in 1957. Today they are still one of our most important sources of information. These cameras are placed strategically around our globe and take one picture a minute of the aurora in action. Since the areas covered by these cameras overlap slightly, we are able to see, in a continuous line, the area any given aurora encompasses. The films taken around the world by these cameras are kept here at the World Data Center. The evaluation of these all-sky records is part of my postgraduate training. These excellent research facilities give me the opportunity to keep up to date with the latest scientific developments. And so the research begun by Professor Loomis was carried on by many men, incorporating more modern techniques. Dr. Chapman had a profound respect for these men whose creative research laid the foundation for modern investigations of this polar miracle. In the words of Dr. Chapman.
I have been fortunate during my long career to be associated with many distinguished scientists. In the 1920s, Dr. Ferraro, when a PhD student working with me at London University, helped to originate the concept of a cavity carved by the Earth's magnetic field in a stream of gas from the sun.
Theirs was the first satisfactory explanation of the relationship between sunspots, magnetic storms, and the aurora. It begins with the sun. An explosion takes place in a group of sunspots. A stream of ionized gas spurts out into space, finally intercepting our planet in its orbit. But the Earth's magnetic field acts as a shield against this cloud. These charged particles are deflected around the Earth, shaping a hollow in the cloud. Dr. Chapman and Dr. Ferraro knew that this constant flow of particles compressed our magnetic field. They felt that this compression might explain the fluctuations of this magnetic field during a solar disturbance. But how could these particles enter our planet's atmosphere? Obviously, somewhere in this void, the particles must enter our magnetic field. The aurora is glowing proof of that. Dr. Chapman knew that in 1931. How could their theory be proved? 32 years later, November 1963, the IMP satellite was launched. It carried a load of scientific instruments. This interplanetary monitoring platform orbited above the equator for 183 days, and the data it collected did prove several things. The magnetic field of the Earth was compressed in the direction of the sun, just as Dr. Chapman had theorized. But on the far side of the Earth, the IMP recorded no disturbance of passing out of this magnetic field, even though its orbit carried at 30 Earth radii, more than 120,000 miles, into space.
It conclusively confirmed the existence of the magnetosphere bounded by a shockwave region, but there are many riddles of the Aurora that it did not answer. But the answers are sure to come. Sometime, somewhere, new clues will be found. Maybe we have some of them now and just cannot yet interpret them.
Dr. Chapman was very pleased with the findings of the satellite. The theory that he and Dr. Ferraro had proposed 32 years before was finally proved by the newest of man's scientific instruments. We graduate students were quite excited about this use of satellites, but Dr. Chapman quickly reminded us that some of the discoveries made at the turn of the century were just as exciting. For instance, in 1909, Dr. Sturmer, a Norwegian scientist, photographed the Aurora from 2 different points on Earth simultaneously. His method made it possible to determine both the height and location of the Aurora. Dr. Chapman's lectures showed us that today, though we use much more complex means, we are still gathering the same sort of information. Today we can bounce a radio wave off the Aurora, and by measuring the length of time it takes the echo to return to Earth, we can pinpoint its location, even in the daytime. So research in the Aurora continues.
There will be from time to time phenomena different from and more remarkable than those we've yet observed. The evidence got at a place like Esther Dome, it will be one important token of such exceptional events.
At Esther Dome, I worked with the team recording information on auroral activity. We began making preparations in the afternoon. The all-sky cameras had to be checked. Are the lenses centered? The mirror in the dome free of frost? The new turret, holding a modified television camera, was checked for alignment. The auroral intensity recorder was prepared. New tape was loaded into the spectrograph to record the content and makeup of radiation from the Aurora. The television film recorder was loaded. A final call was made to Point Barrow. A heavy overcast there. Would our weather hold? Sunset. Still okay. We needed only one thing. The Aurora. An hour later, the needles on the intensity recorder began to quiver. There was going to be plenty of action in the skies tonight, and action there was. For over 3 hours, all eyes and instruments focused on the Aurora as the all-sky camera recorded this brilliant display. We knew that the night had been a success. We had exact measurements of the intensity, location, and magnitude of this particular aurora. This information would be added to other data, and we hoped that someday it would help establish a full explanation of the mysteries of the aurora. Years ago, in that high school classroom, I had no idea I'd be here today, working with other scientists, working to meet the challenge of unanswered questions. As I think back over those years, I can see Dr. Chapman's influence on me.
What will you do in science? Where will you go? Maybe you will be the one to circle the globe across each pole, north and south, in a satellite. There, looking from above, the whole grand spectacle of the aurora, spread over the dark Arctic winter sky, may be open to your view, using new, more sophisticated instruments. Thus, man may overcome limitations to his understanding of the aurora. This may be your experience, or you may in other ways be one of the long line of workers who have built up our knowledge of this fascinating phenomenon.